All right, welcome to the TCWG 2015 Roadmap Review. My name is Ryan Arnold. I'm the Linaro Toolchain Working Group Engineering Manager. This presentation will be about 40 to 50 minutes. I'll try to leave 10 minutes at the end for questions, but please feel free to interrupt me and sidetrack the conversation during the middle of it. I'm sure some people will, and I'm fine with that. So the reason I put this presentation together is because I find myself putting this presentation together regardless of whether it's being presented or not and handing it out to individuals. So I figured I might as well just do it as an actual session and hand the slides out to those who aren't able to attend the session. All right, so we'll start here on first page. So we'll start with the priorities, discussing what our priorities are, our high-level roadmap between our two main tool chains, GNU Toolchain and Llvm Toolchain, some of our ongoing efforts, which describe some of our product offerings, and then we'll talk about some specifics of the GNU Toolchain and Llvm Toolchain development projects. So our priorities for this year fall into four categories. These aren't all inclusive. Many of our activities fall outside of those, or our efforts that we continue to maintain but don't show up as high priorities. What this is basically the high visibility things that our members are interested in that we feel we can execute on this year. These are in four areas. We have our GNU Toolchain development continues to be our highest priority and our item of highest interest to our members. We also have our toolchain releases. That's our product portion of what our team does. We have our Llvm developments, which are up and coming, and members have put a high priority on those. And finally, member requests. So these are issues of interest to individual members or a collective of members. So our strategy with our priorities this year is to align our development effort toward 80% development, 20% products. So keep that in mind when you come and talk to me and talk to us. We have to try to find how we can fit your requests into that strategy because that really does come down from the top. That's why you're members of Linaro in the first place. And yeah, we do realize that you have product needs and product desires, but I have to balance those with Linaro's mission. So our methodology is be more efficient through automation, and that is a challenge actually. So starting on the GNU Toolchain Roadmap, you see these three colored boxes. The blue are things that we're executing on right now that we feel we'll accomplish here in the next few months, I would guess. Green are the sort of midterm. We're looking at like a 6 month time frame to when those should complete. Some of those might push out. Always keep in mind with any of these, especially if there's an upstream component, they could slide out months, many months in fact. And our long-term efforts are our amber colored bars. So these aren't necessarily long-term because they're large projects. Some of them are. They might be long-term because we don't have staffing. They might be long-term because they're a large project that we're going to staff for a long time with low effort. So in fact, if you look at the GCC modularization effort, that's something we have an interest in the long term, but we realize it's really a long-term investment that we can put people on that are slowly working toward this goal. The end result of that will be pretty amazing, but we're not going to just staff up the entire effort immediately. We'll talk about some of these individual efforts later. If you see one in this list that we haven't touched on that you are interested in, please let me know, and we can address it. And then, at the bottom bar down here, we have the ongoing efforts. We'll talk about those as well. What's kind of interesting is if you look at that list versus the top list, and then you look back and you think about that 80 to 20% I was talking about earlier, you might see that it's a bit more unbalanced. So you're seeing a lot of ongoing effort. We would like to make that top part a little bit heavier in the future. So looking at the Llvm Toolchain Roadmap, this one's a bit different. This is much more selective and not all-encompassing, but there are a few main elements here that you're going to see, particularly new elements. So you're familiar with Llvm Linux kernel. This has been something that we've just slowly been working on over the last 9 months, I would guess. Our our role in the LLVM Linux kernel project is more stewardship, facilitating conversations, and fixing things in the LLVM compiler that the Linux kernel finds objectionable. And also encouraging Linux kernel developers to write conformant code. So you're familiar with that one. Llvm Performance, you'll see that's got a red star on it. Most of the members have indicated that that's one of their primary interests for the Toolchain Working Group. Interestingly, you'll see it's long-term due to lack of staffing. I've been having some trouble getting the approval to get someone to work on that. The conversation around whether to staff performance or not in LLVM continues to be something that the steering committee works toward, or is working on. So hopefully we'll see something in that area soon. You're familiar with the LLVM incubation? Yeah. What about it?
What are these?
What are the sanitizers?
Yes, sanitizer pods.
Oh, we'll get to that. I have a slide on that. You're familiar with the LLVM incubation for AR64? That's the work that Renato's been doing tirelessly for the last, what, year and a half, 2 years?
2 years.
2 years. So he'll continue to do that work. But then you see some new efforts here. You see Llvm Linker for ELF on AR64 and AR32, and LLDB. So these are some new developments, and we'll discuss those later. Also, LLVM thread sanitizer on the bottom. And Matthias asked about that, but we will also address that later. Part of that LLVM incubation for AR64 is ongoing developments and fixes, but part of that is also the work that Renato does in the community, that being his releases, community maintenance, build bots, libraries, Linux kernel, mediator, facilitator of discussions
Android.
with, what? Android, yeah, pretty much everything. Everything that's not one of those upper bullets. So we'll address some of these specifics in a little bit. Any questions on this slide or the previous one? Just that come to mind right away? No? Okay. So let's look at our ongoing efforts. We have the two main groups, GNU Toolchain and Llvm Toolchain. So our GNU Toolchain efforts are centered around our toolchain products. So our members have high interest in these products. Many of you see Linaro as a group that can provide you with toolchains that you can use for proving your features, proving performance, building internal tools, building internal products. So we have a number of products that we do release. These are binary toolchains and source packages. The very first thing that we're doing in this list is this monthly backporting. So we're taking patches out of GCC trunk and backporting those into Linaro releases and running validation against them. You also see our binary releases. Those are now on a quarterly basis. I haven't had any, we recently switched to quarterly basis, and I think people are relatively okay with that. We haven't heard any feedback that says that monthlies are necessary, so I think we're going to continue with the quarterly basis. I think it's working well.
So one comment that I heard is that not everyone is aware of the switch. So there's, people still go to the website and look for monthly binaries and surprised when they don't find them. So just make another announcement here.
Yeah, so as we announced at the last Connect and as was positioned in Connect in Macau last year, we have moved to a quarterly binary release process. And what this does is this gives us the time to put in more effort to guarantee that these quarterly releases are more stable, have more patches. Basically, one of the main reasons for doing this also is that we talked about 80-20 before. The effort to make a source release every month and do a binary release and get that posted and get that validated and fix any bugs and find any problems and improve the infrastructure every month, that's really not achievable if you're looking at 20% effort on my entire team. So we needed to move towards something that's more sustainable for the team. So we are now on a quarterly release process. There are sometimes exceptions. So you might find, based upon when the GCC source release is or new version release is, we might move that quarterly 1 month this way or that way, but in general we're sticking to a quarterly release process starting in February. So we'll see a quarterly binary release this February, in fact. And so at the end of
that we still create the monthly release directory with a symlink to the quarterly release.
yes.
And we don't need to tell people where we connect. They will see whenever they get it.
Yeah, that's a good point. Renato had suggested that we have just the regular monthly release directory point to the quarterly release. I was talking with Fabo a little bit about this, and we need to do a little bit of work on the website infrastructure to be able to support that, but that's a good idea. So what you'll also see here is the periodic GNU Toolchain package releases, glibc, binutils, GDB. You're going to notice if you go into the releases.linaro.org, these are not monthly. There is no reason for these to be monthly. What we do is kind of keep an eye on the important features and patches in these packages, and we release those as necessary. There's really not a high enough volume in most of these packages to justify the work that goes into an actual monthly source release. All right, and just to wrap up the sort of toolchain products is the monthly toolchain benchmarking. So we are just getting our automation story in place for toolchain benchmarking. It's actually an incredibly challenging problem, especially when you start looking at wanting to benchmark across different targets and hold your parameters constant. And so it's a very challenging project, and we're getting it close to where we want it to be. Now, what this is for us is toolchain monthly benchmarking is my team's tool to improve my team's output. This monthly benchmarking is not intended for a marketing tool for Linaro or a marketing tool for members. We may have been asked in times to do some of that work, but we really want to see this as something that we provide for ourselves so that we can improve our products. And then finally, part of our ongoing development is, our ongoing effort is development. So these are the things that we are tasked to do continually. Mainly what we do here is maintenance, so this is bug fixing. So we share that burden and responsibility with ARM engineers. We generally tend to focus on bugs that come in related to our tool chains. ARM does, I think, more of the upstream trunk level bugs that they find. We also work on Gcc Performance development, so this continues to be one of our major efforts. We also have system library performance improvements and toolchain validation automation improvements, and also our debugger story and improvements in our developer tools, which I didn't actually put on the list but should have. So in the LLVM toolchain, we have many ongoing efforts as well. All these things in this list are done by Renato. So I don't know how he does it all, but he does. Is there anything in particular here? Yeah, Max.
So, question, where does one download Linaro LLVM release?
So I've been actually asked this question a number of times recently, and it's actually a very good question.
llvm.org/releases.
Yeah, llvm.org/releases, but as Renato will point out, even those are exercises in integration and periodic checkpoints to verify that LLVM features and that the ability to build LLVM releases is assured. So what's interesting is that the way companies use LLVM is that it's not the GNU Toolchain model. They pull LLVM and they integrate it into products and they build their own products on it. So the idea that we package our own versions of the Llvm toolchain doesn't really make a lot of sense, because that's not how companies tend to use the Llvm toolchain. That's not even how we would do it. I don't know what we would do that would differ from what the Llvm community releases do. But in the case of Android, it makes sense. That's why I stumbled there for a second, because I was going to say Android or AOSP, but then I was like, oh wait. It's a little different with AOSP, because there is patch sets and extra things if you want to build a Linux toolchain versus an AOSP toolchain, for instance. So yeah, but Renato, is there any? Can you explain this a little bit better?
Yeah, so there is a.
Let's pass the mic to Renato.
There is an effort in building stable LLVM releases. So since last year, we're already doing patch releases, and they are mostly for people like you that need some stability, but they're not like long-term commitments. And if somebody finds a bug in 3.5.1, we say, yeah, use trunk, because we don't care, and nobody's going to fix in 3.1. They're going to say, I use 3.6.0. Oh, but I'm based on 3.5.1. Well, not anymore. Now you're based on 3.6.0, and I don't care. So all the effort, because I actually argue for having long-term releases, and they say, look, this is your problem. If you need it, you maintain it. You release. So the only guys, I think, is an AMD guy, and he's doing this more or less on his own for his own purposes. And well, since he's doing, everybody else benefits, and it's fine. So if we need something more stable and longer-term support, we can do the same. We can say, look, we're releasing 3.5.2 and 3.5.3 and 3.5.4 because we're still using this thing. So if we want this, then we have to invest in it. As usual, if you need it, do it, rather than wait for, we don't have a large community needing it. So if we do, we have to do that ourselves.
Yeah, and in the case of the GNU Toolchain, it's the upstream community that maintains release branches. We help there, but there is a whole community to do that.
Yeah, so it's to do that work, all of the effort would be on us, and that's a lot of effort, actually, especially for one person.
But if we need it, we have to invest in it.
Right, and that hasn't been identified as a major need at this point. Are there any other questions on that area or that topic? No? Okay, let's move on.
Yeah.
Okay.
Yeah.
Bernhard Rosenkranzer gave a talk at FOSDEM about building Mandriva using LLVM or Clang. So do you know what kind of patches he needed for?
No patches. Not in LLVM.
And not in Clang?
No.
Yeah, we do it in Gentoo too.
Yeah, it's been a while, a few years already there.
Was the kernel built with LLVM too?
Yeah, no
Oh.
patches.
Wow.
In LLVM and Clang, but patches in the kernel.
Oh, right,
The
okay.
kernel code is horrible.
All right, so just to do a quick tour of the Linaro Toolchain products for 2015. So we have two main things we do, source package releases and these quarterlies. I spoke a little bit about the source packages already. A good thing to note is you'll see this is the first instance of Linaro GCC 5.0 backports, the monthly release. So GCC 5.0 should show up sometime in the March to April timeframe, I believe.
5.1.
Oh, did they? Is that how they're doing it now? Oh, I got to change all my charts.
No one uses a .i release, we'll call it .1.
Yeah, so
Releases are not reliable.
nobody really knew what the naming was going to be, so that was discussed last year, and I guess I'm a little slow on picking that up. But the implication here is our 4.9 monthly quarterly will go to maintenance, and that will continue to show up quarterly. Well, actually, that will change to showing up quarterly, so you'll see that quarterly source release. My team will push back strongly on backport requests for GCC 4.9, unless they're on a quarterly basis. We're moving our main effort to the 5.0 or 5.1 monthly source release. glibc, binutils, GDB will continue to be as needed, and our quarterly binary releases will have our 4.9 quarterly and our 5.0 quarterly.
Where are 4.8?
Oh, 4.8 is retired, and you'll see that on this page. So this one's wrong too, apparently. That should be 5.1 on the bottom, but on 4.8 you'll see our 4.8 last maintenance quarterly release will be this February. So that's being retired, unless something catastrophic happens with the GCC 5 release. Everything might slide, and we might continue to have a 4.8 release, but I don't predict that that would happen.
Will there be a Linaro release based on the expected 4.8.5 FSF?
So what I've done, and I don't have it on this chart, is what we did last year for 4.7. When 4.7 tagged, you requested that we do that one last update for the source release so that at least Linaro picks up that last FSF merge. So we'll continue to do that for 4.8. We will do the FSF merge for 4.8.5. I should probably just put that on this chart because I'm kind of carrying this chart between presentations anyway. So are there any questions on this chart? No? Okay. So just one thing to note, you'll see down there on Linaro GC50 sources, that first box has slash through it. That's telling us that that might happen or it might not. This is really something we can't control. So our release will be based upon when the GCC community does that branch release. Okay, so if we look at the GCC stable backporting effort, this is our effort that we apply to the existing upstream branch, release branch. Our target is 25 backports a month. The reality is we're generally exceeding 25 backports a month, though sometimes there are scenarios and situations which lend us toward not hitting 25 a month. For instance, when we moved our lab in Cambridge, we moved our entire company headquarters, which meant everything moved, which meant we had a lower number of backports. So if we look at the next page, you can see that those backport counts. The interesting one there on the bottom is the lab move, and another interesting one is that second one. There just weren't a lot of backports available at the time. So I'm going to back up here and we'll get back to there. So our objective is to increase our efficiency of backporting, to provide ourselves greater flexibility, to staff other initiatives and more interesting initiatives. The point of me pointing out this objective is that we have a target of 25 a month, and I'm going to try to keep us to that target. We won't have a problem achieving that target, but I don't want to overcommit beyond that target because I want to be able to use my engineers to staff development efforts and not just massive amounts of backports. So if we look at our methodology for this, the backporting effort generally follows at the beginning of the GC product release or the branch release. We follow this first patch at a trunk is the first patch backported. So we basically just backport patches from trunk. And then later in the release cycle, as the patches sort of queue up in trunk and we're unable to get all those into our tree, we start to more selectively backport. So I believe, was it December, Yvonne, when we backported something like 25 performance-based patches rather than just bug fixes and whatnot? So we focused more on performance in December. So we're starting to get toward the end of the life cycle of that particular release. We did focus on performance. And of course, we respin releases when necessary. So this is really important. If you have major bugs, security issues, hardware errata, we really need to support respin. So we do indeed do so. I believe we had one in September. So we'll continue to do that. So we already looked at this a little bit. The interesting thing on the bottom is you see the sum total last year was 299 plus the FSF branch merge commits. To put that in perspective, the year before, I believe, was 177. Was that right, Yvonne? Yeah. I actually had lost the IRC conversation where you gave me the same chart for the 4.8 toolchain, so I couldn't put it on the deck. So earlier we talked about our Linaro validation automation. So this is a complicated process. And this sort of describes the high level of what we're doing. The green checks mean that's what we're doing. The yellows or the reds, I guess they're amber. The amber stars are things that we're trying to do and will be there soon. So we do backport automation using backflip. So this is a tool that Yvonne wrote that presumes that the backport will be trivial. So his tool will just backport a patch and try it out, and if it fails, there's a little bit more effort involved. But this is a great tool. This is what really brought that number of backports from 177 to 299. Is that true? Would you say that's true?
Yes, sir.
So that's been a really good tool, and in fact, I think Yvonne could just have backflip, backport tons and tons and tons of patches, but then the rest of our validation infrastructure couldn't keep up. So this triggers a Garrett review or a Git review. This is really kind of neat in that he can do a backport in backflip. I believe you push a branch and then Git review just says, hey, we've got this patch that needs to be reviewed, and it fires off a validation via our Jenkins trigger automation system. And then this just launches validation on a large group of targets. So this triggers this automated, this automated validation. So what we're currently sort of fixing up is this launching a performance analysis, launching or triggering benchmarking automation entirely, getting the results back into Garrett. So these are complicated things, and we're getting close with them. What we're going to be doing soon in the future is that all of these backports will create the release, and the release will have its own validation. And then we'll create the binary release, and the binary release will have its own validation. And they'll all be triggering performance analysis for us so that we know if individual backports have regressed performance, for instance, or we'll be able to have the results on release over release benchmark results. So from the first backport to the quarterly binary release, we want to hold the build environment constant as possible, so that the resulting toolchain is as stable as possible. So we're moving away from a system where backports were validated in an environment that was different than the environment that was used to build the toolchain, that was different from the environment that the user would run the toolchain on. So we're trying to close the loop. Matthew, question.
So what are you using to validate? Is it just the GCC test suite? Are we doing validation with more special packages or things from distro that we know key packages that cause compiler issues? So
at this point, it's mostly compiler and binutils and GDB it's in my plan to extend what we're testing. But one thing to note is that a toolchain bootstrap is a good test of itself. But there are always places that find bugs, and there are people who find bugs all the time. Doko, for one. But yeah, we are going to be...
The build and baselines guys are working on a lot of that stuff as well, not directly for our benefit.
Okay. It's just, so yes, just from my own experience, I find things like build and Qt or whatever, and there are other packages that just seem to find the bugs.
So we're currently having conversations with the other teams about where does this team's responsibility end and where do the other teams, who are the consumers of our products and what do they do. So yeah, ultimately what we want to do, and maybe this is what Robin wanted to say, was that they have Jenkins jobs which build OE, for instance. So our Jenkins jobs, when we successful, we can trigger their Jenkins jobs. So that's our plan, right? Is there anything else you wanted to point out?
Yeah, basically we've been we've been primarily working on getting the whole backport and validation process going, and once that stabilizes, which it kind of has been lately, then yeah, the idea is that our Jenkins job will fire off builds of like Android and Open Embedded or whatever distribution the builds and baseline team already does, and then use Llava to ideally boot that kernel and make sure that it still works. And this is definitely doable and stuff, we just haven't got there yet.
So, I mean, if you build Android or Open Embedded, you most usually cross-build. So the only thing which you catch are, internal compiler errors. But the more problematic things are, from my point of view, are wrong code issues, which you usually only discover when you try to run the things you built. And that's something which I think we had we talked about in Macau already and in San Francisco last year. That would, I think, help to make the Linaro toolchain much more reliable.
So a comment, is it done? Yeah. I think we want to do that. The current limiting factor is the performance and amount of native hardware that we have available. Right now we are short on it, and we are working to get more.
Yeah, and then I mean, on the toolchain side, we don't want to spend a huge amount of time, duplicating all the work Builds and Baseline does. So if Builds and Baselines has an ability to, let's say, build Ubuntu, then we would just want to trigger that job. And once, if that's available from that side, then we would be glad to build it because I agree, it's the better test.
Yeah, we'll build the boots
But
as
we
well.
don't want to maintain build infrastructure for kernel building and distros and all that other stuff ourselves because we don't really have the staffing for it because I'm one
It's
guy.
not just staffing, it's just not.
Yeah.
We're not the best people to do that at all.
Yeah, exactly.
Can you
We
pass
should not do that.
pass the mic?
Toolchain guys.
Is it just me or?
You.
Yeah.
Well, we do with our binary releases, I believe. Rob installs it on the target and then runs the test suite running installed on the target. So we are actually running the compiler and running applications the compiler builds with the binary release. Go ahead.
So in open embedded session, we discussed about kind of like runtime testing and kind of teaching actually open embedded, have actually a bunch of recipes that you can exercise different kind of like test suits in different actual open source actual packages. And I basically, yeah, the build actually will catch actually some errors in the compiler, but there are actually kind of also runtime actual issues. So in natural actually if open embedded uses actually uToolchain directly actually from the Git, right? So you may kind of you may actually have a stake in this actual activity in terms of like if open embedded will be running kind of like regressions across many packages, you in some sense indirectly actually validate actually your compiler actually as well, right?
Right. Yeah, and we have received bug reports from Open Embedded before. All right, so I'm kind of running out of time, and I've got more slides to go through, so I'm going to kind of start speeding it up a little bit. So we talked a little bit about automated benchmarking. Here's the activities. You can read them. We've discussed them a little bit. I said before it's hard. This is a hard process, and the reality of where we're at is that we have some hardware stability issues. ARMv8 continues to mature and add new options. We'll be looking forward to extremely stable hardware in the near future, hopefully. Also, system image issues. So all of our member partners have different ways of getting kernels and system images onto machines. And for a bunch of toolchain hackers, that's a lot of work. That's just not something we're specialized in. So we struggle a bit with system images and sort of having automation ready out of the box on these machines. So we're really looking forward to rock solid system images and kernel hardware packs for everything that we want to benchmark. Any comments on that, Bernie? Do you think that's pretty good?
Yeah, that's about it.
Doko?
Are these benchmark results available?
So there have been some issues with licensing, benchmark licensing that have been discovered in the last several months. So they will be the monthly or the quarterly binary releases and results will be available soon, but I've just squared away some licensing problems. So that's why you haven't seen any benchmark results for the last several months.
Do you run these benchmarks against FSF releases as well?
In the past, we have, I believe we compared the FSF tree to the Linaro tree. One thing to keep in mind, we don't provide these results to the public. They're provided to members.
So they are not available to me.
Right. That's what I was trying to imply. Sorry, Doko.
Be straight, not nice.
All right, so let's take a look at GCC Performance, just some areas and examples. We've kind of concentrated on these 4 areas of performance. There are further areas. The ones you will notice are missing are feature development performance issues. So that's something we leave to ARM engineers. ARM have the new hardware. ARM have the new features. They know about it before we do, so they're most well suited to developing new performance features based on their hardware. So we kind of stick to these 4 areas. The member stakeholder identified performance improvements. That's when you guys have problems and you're seeing interesting things and you come to us. We work on fixes around those areas. We also look at our performance of our toolchain, feature exploitation that's not covered by our business partners. So we're going to start looking at auto vectorization using Neon here in the near future. And then one of our long-term missions is comparing relative gains between AR64 and x86-64. We did some investigations into LTO instruction counts recently in that area. So these are the 4 areas we'll continue to investigate in the future. Another ongoing effort, we've kind of covered this already. Once again, this is all Renato. If you have questions on this, go to Renato. So let's look at some specifics here in the GNU Toolchain development area and LLVM. So I've sort of pinpointed 4 interesting areas. This isn't exhaustive by all means, but I find these ones interesting, and there's been some questions on these. So we have these 4 areas: modularization of GCC, test suite coverage for GDB, ILP32 integration and benchmarking, and thread sanitizers. I didn't mention the ongoing performance because we described those earlier, or the ongoing efforts of Gcc Performance. So we'll get down to the specifics of each of these. So GCC modularization, this one's an interesting one. There were some initial requests for a way to have a single unified compiler driver that could drive both the ARM backend and the AR64 backend. There have been some creative solutions that have changed the necessity of this. But there's also some continuing reasons to keep pursuing this. And the big one for me is that this reduces the number of unique instances of toolchain products that my team has to maintain and release. Customers want one toolchain that supports their target. They don't want many toolchains that support many targets that confuse them, confuse their customers, and confuse their support engineers. Maxim?
10 minutes.
Thank you. We also want to provide a user experience for ARM and AR64 that matches the experience of other architectures. This will simplify all the products that are built on top of that toolchain. Open Embedded, for instance. Just recently, Open Embedded, I believe, got the ability to use 2 different toolchains. What's also really interesting about this effort is we have members who want to deploy and update a single toolchain instance to in-field products to reduce the complexity, support, and delivery. So let's say you're a set-top box company and you have 32-bit products and 64-bit products, and you have to deploy these to 37 million devices. You don't want to have to deploy 37 million different toolchains. You want to deploy one toolchain image, one toolchain package that can service all of your products. But for us, this is a long-term, low-investment effort. This is a big project. The objectives are described here, but that's just part of this project. So this is something we'll continue to work on. 2 of our engineers have been working on this primarily Prathamish, our intern, and Michael Collison, one of our assignees. So looking at GDB test suite coverage, there's gaps in the test suite, mostly between these parity between x86-64 and AArch32 and 64. And parity even between AArch32 and 64. Mixed mode debugging, improving known failures, addressing bugs and debug info. So this is going to be one of our efforts going into 2015 here. We want to guarantee a high quality debugger for ARM and AArch64. We want the experience to be what engineers expect and what they find in other architectures. Yes, Matthew.
So just quickly going back to GDB, one of the issues I think most is that you get a mixture of native and remote debugging, and so it'd be nice if parity included native and remote debugging, which I don't actually see on that list there.
Will, could you put that on the Etherpad? Thank you. All right, so ILP32 toolchain integration and benchmarking. I'm very careful talking about this. Our investigation here has been very targeted. What we're doing, or what we've been asked to do, is take the sources that are available, sort of the upstream sources and the RFCs from the different packages, put them together in a toolchain and see what the performance looks like. So we're continuing to work on this. What I can tell you is that the support is there in the compiler. There continues to be questions about the patch set in the kernel. And before the kernel story, or before the glibc story can be completed, the kernel story needs to be completed. So that means that there are questions in glibc as well about ILP32 and the implementation. So we're still waiting on the kernel, and we're still waiting on glibc. And we are currently investigating the performance characteristics. That's information that will be shared with members when we have it available. So as you saw before on one of the earlier slides, this isn't, at this point, this is not a long-term investment. This is simply investigation. And then thread sanitizers. So Matthias was asking about this. We're not just working on thread sanitizer, we're also working on ASAN, which is the address sanitizer. So what we want to do here is implement the thread sanitizer for AArch64. This requires enabling the GCC configure stuff for TSAN. It was really built for AArch64 or for x86-64. I mean, it really was not built to be multi-architecture. So there's been some major porting efforts there. There's some issues in the virtual address space designations that we're having to work on for AArch64. Different SoCs have different virtual address space sizes, so we have to make some accounts for that. We also have to do the upstream port enablement into LLVM and GCC, because GCC uses configure, LLVM uses CMake. It has to work in both places. This effort is, we have our GCC engineer working on this. The point is to get this in place for GCC. But to do that, they have to work with the LLVM community. So the reason for doing this, our members want powerful analysis tools. So let's see. I wanted to wrap up early, but I don't think I'm going to.
5 minutes.
Okay, 5 minutes. So Llvm toolchain development specifics. So these 4 areas. I'll just go through the slides directly rather than reviewing them. So Llvm Linker. This is an effort to port Llvm Linker to ELF ABI for AArch64. So you'll notice there's LLD. What you don't see there is MC Linker. So we did a query of our members, and we feel the best strategic position is to pursue development of LLD. But what this also means is that those of you using MC Linker will be left behind in the future. So one of our objectives on the bottom there is to implement features that MC Linker uses that are missing in LLD. And this is really for you, the members, so that we can provide you with a migration path to use LLVM, the new Llvm Linker, LLD. Some of our other objectives are just base ELF enablement for AArch64, interoperability of binaries linked with LLD and binutils LLD, LTO support, and making LLDB linked, whoops, that's LLDB, whoop, that's supposed to be LLD. Making those linked objects compatible with the oldest ABI in the linking group. There's some really interesting things when you start linking in new objects and old objects that are going to take a bit of work. So the reason for this is that broad adoption of an LLVM toolchain will require an integrated link editor. All of you have different reasons for wanting a fully integrated LLVM toolchain, and this is just satisfying that request. So we're also working on LLDB this year. We basically want to implement ARM and AArch64 debugging support for the ELF ABI in LLDB. So the objectives are pretty clear. This is, if you look at it one way, you could say parity with what GDB provides, but in some ways it might exceed what GDB provides, and in other ways it might not. What we really have to look at is where are members going to use it, what environments are they going to put it into, and what do they expect. So we're going to support the most common existing devices first and move to support next-gen or common devices later. So, if there's hundreds of millions of ARM v7 devices, that's what we're going to target first. But also work on that next-gen support. So as we get more ARM v8-based cell phones or mobile phones or whatever, servers, and we'll start working on that support as well. And once again, broad adoption of an LLVM-based toolchain requires an integrated link editor. There are parts of the linker and parts of the debugger in the GNU Toolchain that are closely coupled together and closely coupled with their license that make the subsumption of that debugger into an IDE or particular IDEs problematic. So this is really going to enable members to have some choice in how they integrate debuggers into their products. So Llvm benchmarking. So this is something you'll see at the bottom. This is partially staffed. We need to do a base amount of benchmarking for our own development efforts. And this is what we can staff. What we can't staff is larger efforts, big benchmarking suites, tons of targets. We would like to be able to do that, but we really don't have the staff. What we're going to be working toward is just enabling our infrastructure, our validation infrastructure and benchmarking infrastructure to be able to build LLVM toolchains and benchmark them and trigger jobs. This is really going to be in no condition to satisfy member requests or do anything overly complicated in the next year. So this is a prerequisite to any in-depth Llvm performance effort. And that's this slide, and you'll see the big red not staffed on the bottom. Like I said before, this is something we continue to discuss with the steering committee, how we staff this effort. There is a lot of interest here, but currently there's no staffing on this. What we want to be able to do is look at Embassy and Spec 2K and Spec 2K6 and auto vectorization, and work on performance issues we find. Hopefully we'll be able to get there soon. But yeah, not staffed at the moment. And I think that's about it. Were there any questions that you were holding till the end? Yes, Matthew.
So GCC 5 point whatever is due out. What efforts are being spent on helping the community get that out the door so that you can make a release?
So last July, I talked with Jakub Jelinek, who is generally the release maintainer, about what kind of help he wants. And he was quite adamant that what he really wants is people to look at bugs, fix bugs. So our bug solution effort is centered around our products. Our efforts are generally responsive, so we'll respond to the community. We'll respond to the community when they move, but I don't see us being able to put a large investment in making sure the release releases as early as possible.
We will fix all blocker issues for ARM and ARC64 in the upstream so that the release can be made.
Right, but I see
but not
that
for
being
x86
Well, no,
blockers.
that's fine,
Yeah.
yeah, and I see that being a partnership with ARM as well. I don't think the ARM engineers are going to abide, blockers blocking the release for their architectures. So, but yeah, so that's not us alone. We'll work with member toolchain engineers as well.
As of this moment, I think there are 2 or 3 blocker issues for ARM and ARC64, and we are working on them. We are working on them.
I believe one of them is ASAN.
Yep.
Yep. And I believe that has to do with the different virtual address space sizes as well. Other questions, Matthew?
No,
Okay. Anyone else? Matthias? Okay. Well, I think that wraps it up on time. All right, thank you very much. This presentation should be available on video as well later. So thank you for coming. And please contact me if you have any further questions.